Hello. I'm happy that this 2022 is very good year for Bombshell publications. This is what we are going to talk about today. Another study, which was published just a couple of days ago, showed a very curious connection with neuroimaging studies, specifically MRI studies, and behavior. So the main question is whether MRI studies, neuroimaging studies, can actually explain your behavior. So the answer is no, or at least not yet. The main character in this story is Scott Marek, who was dealing with effectivity in certain intelligence tasks and the differences in MRI in kids. They try to figure out what is going on with individual differences in 2,000 healthy kids when they were resolving certain cognitive tasks. And to make things more plausible, he actually split this sample of 2,000 kids, MRI, and the results of the tests, and analyzed it completely independently from his colleague. And when the results were in, he was surprised that those parts of the same sample individually analyzed completely different conclusion. So how it is even possible? As a neuroscientist myself, I'm trying to figure out what are the results of MRI studies or fMRI studies before I embarked on research, for example, in electrophysiology, because I believe that the results of neuroimaging studies are evidence-based and they are giving you information over structural or functional information which are coming as a conclusion of scans that they are analyzing. But the curious conclusion is that very similar to what I was discussing here about applications of AI in health here, in connection to sample size, turn out to be the same problem here when neuroimaging studies are in question. If you're working in neuroscience, you might decide to use some neuroimaging as a technique of choice, like MRI, fMRI, DTR, maybe CT scans and things like that, because this is really objective-based methodology, how we can make conclusion about physiological process going on in brain. But it seems to be quite a bit stretched to connect the individual changes in some structure of, how should I say, the extent of neuroanatomy with behavior, which is a completely different concept. In 2019, after this very sobering result, Dr. Marek decided to join forces with other colleagues and try to analyze the big database coming from UK, consisting of 50,000 different scans, 50,000 of people who were previously participants in other neuroimaging studies, and to analyze whether based on individual differences, we can really say something about behavior. In 2019, when they started research and posted the first preprint of the study, which is now published in Nature, I'll give you the link below so you can read in detail what is it and what I'm referring to. They actually try to calculate correlation between neuroimaging-based data about structural and functional details about individually different MRI scans and something which is behavior or some cognitive agency. The thing is that majority of neuroimaging studies are small, meaning that they have pretty small sample because recording MRI or fMRI is pretty expensive. This is why many people are part of collaborative studies, but even in collaborative studies, the sample which is smaller or equal to 500 participants is considered large. When they simulated and analyzed the data they actually draw from the UK-based Brain Neuroimaging Bank, they actually find that even pretty large studies, it is possible that you have 20, 30 participants, or 50 or 100 or a couple of hundreds, but it turns out that only reliable results you can have that you have more several thousands of participants, which is extremely expensive. So after they explore the database, which is anonymized and available to other researchers by UK organization, they actually find out that the calculated R demonstrating the connection between neuroimaging findings and behavior, R is in average 0.16 and median was 0.01. And this is for a study which has something like 2,000 participants, which is considered large. Based on that, they concluded the correlation calculated of most studies' average size of the study which is published in the literature is rarely larger than 0.2, which is really modest result. So the conclusion is that majority of the published data, as Ioannidis showed in the studies which are using p-value as the basic parameter to show whether something is statistically significant or not, they basically find out that majority of published studies which are connected MRI or fMRI findings with behavior are having very weak evidence that we can establish the connection. To do that, the studies from now on has to have much larger sample sizes, which is true also for any AI applications that you have. Majority of those studies which have typical sample size for neuroimaging studies, which are using MRI or fMRI to have conclusions in some behavioral information, they have significant results in less than 5% of data, meaning that they're on the level of error in frequency statistics. Really bombshell study, if you ask me, putting in question majority of the published literature which are using neuroimaging to explain some behavior. In 2019, neuroscientist Scott Marek was asked to contribute a paper to a journal that focuses on child development. Previous studies have shown that differences in brain function between children were linked with performance in intelligence tests, so Marek decided to examine this trend in 2,000 kids. Brain imaging data sets had been swelling in size. To show that this growth was making studies more reliable, Marek, based in Washington University in St. Louis, Missouri, and his colleagues split the data in two and ran the same analysis on each subject, expecting the results to match. Instead, they found the opposite. I was shocked. I thought it was going to look exactly the same in both sets, says Marek. I stared out in my apartment window in depression, taking in what it meant for the field. So we know already that many people who are focusing their whole careers on this kind of connection between anatomical or functional MRI or fMRI with explaining behavior or development things is basically junk if you're doing that on very small study. Basically, typical studies in this field are having, let's say, a couple of dozens of participants or couple of hundreds participants, but Marek showed in the study published on March the 16th this year that only if you have something like thousands participants, your connection with behavior can be really relatable and meaningful. So basically he says, Marek and his colleagues show that even large brain imaging studies such as his are still too small to reliably detect most links between brain function and behavior. Which brings me to the main field of my research, which is depression. There are a lot of published studies of certain neuroanatomical or functional information extracted from exactly MRI or fMRI studies, which are linked to behavior, where scientists actually try to learn what the differences between people who are healthy and people who are depressed have when you read their brain scans. And we already know that individual differences are significant, but that significant individual differences doesn't lead to pathology, meaning that you really want to find a correlation between neuroanatomical difference or neurofunctional difference, which is extracted from neuroimaging data, really have effect sizes which is meaningful in practice. In essence, your conclusions about such a complicated concept as behavior to connect neuroimaging data really have to have large data sets. And majority of papers which are concluding that certain neuroanatomical differences are the reason for such a big shift in behavior, like having clinical depression, are under the question now. We have to repeat them. And another thing is that Marek and his colleagues basically showed on a really big database, which consists of more than 50,000 of MRIs, showed that even in large studies which had more than 2,000 participants, and today this is considered to be really large data set, have only 25% possibility to be replicated. And this brings us again to one of the huge problems in neuroimaging studies, and not only in neuroimaging studies, in studies which are concerning physiological and psychological phenomena, that you really have to have as large as possible data set. As I spoke about that previously, about replication of AI applications in health and the studies which are small, here we can see the same pattern. If you have modest sample of, let's say, a couple of hundreds of participants, you are tending to have calculated higher correlation. And if you replicate the same protocol on much larger sample, your correlation will drop. So this is not nice to publish. And again, we are here talking about cherry picking and publishing only the positive and significant results, not even mentioning those which are not significant. So I said in the beginning that this publication by Marek et al. 2022 is a bombshell for the field, and it will have devastating effect on careers of many people, because now we can figure out that majority of the things that we thought we know based on neuroimaging are simply false.